Let us continue with chemistry. This is our session number 9. Okay. Let us have a look at question 23. Right. In question 23, let's put you down here as question 23 for posterity. If we heat 75 grams of calcium carbonate and we find that we have 14.5 liters of carbon dioxide at STP. STP, that trigger thing. STP must have something to do with 1 mole equals 22.4 decimeters cubed at STP. Cool. We've remembered it. Okay. Calculate the percentage yield if the other product form is calcium oxide. Right. So step 1, all right, we always write down a balanced chemical reaction, right? So let us do so, right? Let me just get to my nice layout over here. So I'm going to say calcium carbonate, CaCO3 as a solid. And this is going to calcium oxide, CaO plus CO2, all right? And this is a gas. Calcium oxide is a solid powder as well, right? Now, step 1, remember in this thing, those of you who did this with me, with the table format, the recipes, step 1, okay, we write down the mole ratio. Because we check, is it balanced? Calcium, calcium, yes. Oxygen 1, oxygen 2, carbon 1. So it's balanced. So therefore the mole ratio, the thing I also called the recipe, is 1 cup to 1 cup to 1 cup. Right? But we have to get to the mole hole, correct? Because that's where everything happens, doesn't it? So we draw a line. The next step is we put down what we are given. Given in this case, all right, is, let's have a look. All right, what are we given? Okay, 75 grams of calcium carbonate. All right, and we have, okay, we also say we have 14.5 liters of carbon dioxide. 14.5 liters of CO2 at STP, right? I'm just putting down what I've been given. They want to know the percentage yield. Oh, hang on. What does that mean? The percentage yield. Okay. Well, in essence, it means this. All right. When we're doing this experiment, all right, we've got a amount of stuff. Right? This is pure, and this is dirty stuff. This is pure stuff. Okay. When we do the experiment, the pure stuff goes into the process and comes out with the yields of product, right? But if we know how much this is pure product, right? Pure stuff to pure product. Pure reactants to pure product, okay? This is important, very. So what do we say? We say, okay, I've got a block of stuff here. Here we go. I've got a block of it. This top bit over here is actually contaminated. It actually isn't CaCO3. It's something else, right? So it's not going to take part in the reaction. It's junk, okay? It's just going to lie around taking up space. So the reaction, the chemical reaction that we wrote down at the top here, all right? This chemical reaction, this here is given, this is our dirty stuff, right? Okay, this is the contaminated stuff. This that we got is pure. Is it not? All right? It's pure. Do you see that? Just think about it. We've been given 75 grams of it, okay? And it's not all pure because we're being asked what is the percentage yield. All right? Okay, so now let's have a look. Okay? Let us have a look. First of all, we next said molecular mass is 40. plus 12 plus 3 times 16. I'm working out this one, right? Remember, we put our lines down here, all right? And we're just going to work down. That's 100 grams per mole. Okay. Now, number of moles is, okay, mass over molecular mass. Okay. Number of moles is mass. 75 over 100 is equal to 0.75. Whoops. Let me just make that neat. 0.75 moles. Now we go through the mole hole, right? This is it, isn't it? The green part, this is the mole hole. It connects all of the compounds, elements together in that mole hole, doesn't it? You cannot go through any other fashion. Let's just keep going backwards and forwards through the mole hole. Right, what is the next thing we do? We say, okay, 0.75, all right? Therefore, the mole ratio is 1 to 1. Therefore, we should get 0.75 moles of CO2. Right? If we've got 0.75 of that, we should have got that. In other words, we're saying if it was all pure, right? I'm just going to move this because it's now in my way. My apologies for getting rid of it, but we can always put it back just now. Whoops, sorry. Let's just get rid of all this so that we've got, okay. Okay, what do we do next? We say, okie dokes. Therefore, we should be getting 0.75 moles of CO2, right? How many moles of CO2 did we actually get? I'm going to go to blue. I'm going to say, but we know we have 14.5 liters of trigger STP. 1 mole equals 22.4 liters or decimeters cubed at STP, correct? Therefore, we need number of moles, and we know we've got 14.5 liters. So we cross-cancel. Not cross-cancel. We cross-multiply, don't we? Oops. And what does that give us? It gives us x times 22.4 is going to be 14.5 over 22.4, because that would have gone to this side, and then I'm going to divide through by it, which gives us a, should get 0.75. Let's have a look. 14.5 divided by 22.4 is equal to 64.4. Sorry, 0.644. I'm still in percentage thinking mode. Okay, is 0.644. Okay, so we can say pure yield was 0.644 moles. Okay, theoretical yield was equal to 0.75. So therefore, percentage purity is 0.644 over 0.75 times 100, and that's going to be equal to 0.644 divided by 0.75 is going to be equal to 85.9. Let's say 86%. Okay, right. So we should get 0.75, all right, and we got 0.64. We just check. 14.5 divided by 22.4. 5 divided 22.4 is going to be equal to 0.6473. Oops, sorry, how did that happen? 0.6473. I'm so sorry, guys. 0.6473 over there. Okay. 0.6473. All right. Still very close, but no, it's not 100% correct. It's 0.6473 is that. Therefore, it's 86.3. Oops. No idea why you moved. 86.3%. Right? Sorry about that error. I must have pressed the wrong button. Okay? 86.3. All right? Now, please remember a couple of things about this. Just do it logically, okay? Don't try and do it in your head. Just think logically. Say to yourself, here I've got my block of stuff, right? It's got impurities in it. Therefore, it's going to, when I do the chemical reaction, only the pure stuff is going to go through and do the reaction. The other stuff is not going to be part of the reaction, right? So what we do is we say to ourselves, right, how much should I get if it was all pure? So much. Then we compare it with the number of moles that we got actually out, which was the pure stuff reacting, isn't it? All right. Do you want to go through that again? Let's just go through it again conceptually, shall we? Let's just try and see if I can get it through slightly differently. Okay, over here. All right, and I'm going to say that this piece here is the impurities. All right, so this is pure. So when we put this whole block into a chemical reaction, okay, only the pure stuff is going to react, okay? So the pure piece is going to react and give us, okay, actual moles or masses or concentrations, isn't it? That's the pure stuff is going to give us actual, right? Isn't it? Because that's what we got. But, okay, so the pure is giving us that. So we've got pure goes to pure, doesn't it? But we don't know how much. This we don't know. Okay? So what do we have to do? We have to work from assume this is all pure and see what my theoretical yield. Okay? Let me just go up here a bit. Theoretical yield assumes, yeah, and we all know what that means, assumes all is pure, right? Okay, so it assumes the whole block, okay, the whole block. In other words, the whole mass given, right? That gives us a theoretical yield. And the actual yield, okay, is what we really have, isn't it? Okay, so that's what we really have, and therefore the percentage is the actual over the theoretical, right? And obviously it must be less than 100%. I know that sounds silly, but when you're in a test pressure or an exam pressure and you switch them, you get more than 100%. All you need to do, don't panic. Just say, I've switched them. It can't be over 100%, right? Let's have a look at the next question. Okay. Right. The following acid-base neutralization reaction. Okay. Calcium hydroxide, hydrochloric acid goes to what? Okay. We should be able to say by now, shouldn't we? Okay. All right. Okay. Let me just start and go back down a little bit so I can just keep some space. Not that I really need it, it's digital space, isn't it? Okay, the following acid-base neutralization reaction, calcium hydroxide is a what? It's a base. So we've got calcium hydroxide, all right? In fact, I'm going to start it on a new page. Okay, it's still old school for me. Calcium hydroxide, all right? But now I've got to make sure I balance, because remember, Can you see they've given it in words? Giving it in words is a bit of a giveaway, okay? They're trying to make you fall into the trap. So what do? We say, right, calcium hydroxide, aha. There's a 2 on the outside because that's a +2, -1, and 2 of them gives me -2. Correct? Okay, let me get rid of those. And that goes to plus hydrochloric acid, right? HCl. And this is going to go to a salt and water. It's going to go to calcium chloride, CaCl, and you have to balance again, plus H2O. Right, let's go back over. All right, and now we have to balance them. Right? So if you go and balance, you're going to find that you have to put a 2 there, and if I'm not much mistaken, a 2 over there as well. Right? Now, next step is we put down the mole ratio. The recipe, right? It's 1 as to 2 goes to 1 plus 2, right? Then we put a double line down there. I just like that because that is going to be, this side is my reactants. This side is my products. Like so. Okay. So now the next step is we say, right, what am I given? Okay. Well, let me go back to my thingy. What am I given? I am, we measure the mass of calcium chloride formed as 125 grams. Okay. If the acid has a volume of 750 mils, calculate its, aha. So now we've got another thing. We've got concentrations. Now remember, my guys, given, the next step is molar mass. Next is that. Next is concentration is N over V. So I'm given a volume over here, given a volume of 750 mil. Okay, can you see that? And now the next step is calculate the concentration. So that's where we're headed. Okay, guess what? Moles all the way. We've got to get to the moles. So what do? Well, molar mass of, now let's just go through. The molar mass of the calcium chloride is 40, okay, plus 2 times 35.5. Right? That gives us 111 grams per mole, correct? And I'm going to do the water is 16 plus 2 is 18 grams per mole as well, correct? Okay, then we say, right, the HCl is 36.5 grams per mole and 74 grams per mole, right? Now, what we need to do is we now need to work out N. Well, let's have a look here, because where are we headed? We're headed here to the, I know, it sounds very childish, the mole hole, but do you know what? Any way of remembering it is worth it to me. So let's have a look here. We say, right, what can we calc? Hello, we can calculate U. It's number of moles over here, right? How did we get it? We said, okie dokie. Let's just check. Number of moles is mass over molecular mass. So it's 125 over 111 is equal to N, which is equal to, divided by 111 is equal to 1.126, okay? 1.126, all right? Therefore, how much water would we get off? This is where we use the ratio. Only here do we use the ratio. We're going to have 2.252. Because I multiplied it by 2, because that's the ratio. Let's go the other way. It's also going to be 2.252 moles, right? This one is going to be 1.126. Why? Because this is also a 2. Use the ratio. 2. I've worked out 1 is 1.126. Therefore, 2 must be double it, right? So what do I have here? Can I work out concentration now? Yes, I can. I say, right, it is going to be, concentration is 2.252 volume. What didn't I do, guys? The first thing that I should have done is changed it to decimeters cubed. 750 mil. Okay, I've got to go up to liters. So I'm going up, it's milliliters, centiliters, deciliters, and liters. So I divide it by 1,000, which is 0.75 liters, which is 0.75 decimeters cubed. Divided by 0.75, and my concentration, just let's shift it up a wee bit over there. My concentration here is going to be, of the acid, is 2.252 over that, is 3 moles per cubic decimeter. Okay, 3 moles per cubic decimeter is the thingy there, right? Then they say, right, calculate the masses of all reactants and products and show the law of conservation of mass. Which basically, what do they want us to do? They want us to calculate the mass of all products. So let's go for it, okay? Let's do the mass of all products in red, shall we? Right, let's now go back and fill in, okay, mass, shall we? Well, we know we had 125 grams there, correct? Let's work out what's the mass of calcium CaOH2, calcium hydroxide. The mass of calcium hydroxide, we know the number of moles. So I'm going to use number of moles, mass over mm. So therefore, the mass is going to be N times mm. So the mass here is going to be 1.126 multiplied by 74, right? Which is 83.32. Okay, the mass of HCl is going to be 2.252 times 36.5, which is 82.21. And lastly, the mass of water on this side, all right, the mass of water is going to be 2.252 multiplied by 18, correct? Which is going to be 40.5. So therefore, left-hand side, right-hand side. So what is the mass on the left-hand side? It is 83.32 plus 82.21. Add them up, it gives 165.5. 0.5, yeah. Okay. I'm just ignoring the second decimal there, right? The next one is going to be, let's look on the right-hand side. Okay. And this is where we see if we've made a mistake or not. It's going to be 125 plus 40.5 is 165.5 grams, and they must be equal. Why must they be equal? Quite simple, they must be equal because of the law of conservation of mass. You didn't change. We're not doing nuclear here. The mass you put in is the mass you get out, right? You can't create mass nor destroy it. You can change it from one form to another. Okay, that's the kind of thing that stars do, black holes do it, and hey, guess what? We do it every time we do a chemical reaction, right? If you, for example, take a chunk of meat, right, and you put it in, and you heat it up, right, for say an hour, and then measure how much water came off it, and measure how much your meat is. The amount of water plus the amount of meat left must be equal to the total mass you started with, right? It's the same as the crucible one as well, isn't it? Okay, right. The table, so in this one, theoretical actual yields, right? A theoretical yield is if we assume the whole thing is pure, we work out what we should get at the end. But then we look at what we actually have gotten and work out the number of moles of each, and then we take it as number of moles of actual divided by number of moles of theoretical times 100 over 1. Remember that one? Okay, that's the pure stuff to pure stuff. The other stuff is the contaminated stuff, which doesn't take part. That is why we don't get 100%. Granted, if it was pure, you would get 100%, correct? Of course you would. The other one are these straightforward chemical reactions, the stoichiometry side, where we put it all together. Okay, chemical reaction first, top line, balance it. Write down the recipe or the mole ratio. Draw your lines. Put down given, then put your mass there, whatever. Put everything you're given in its spot. And then put down number of moles is that over that, concentration is that over that. When we get to equilibrium chemistry, we're going to go even further with it, right? Okie dokes. That was pretty good timing, if I say so myself. Thanks for watching that. The next question we're going to be doing, we're going to carry on with question number 25, okay, which is a bit longer. Okay, hope you're doing these with me. It doesn't help if you're not. Just watching me do it, you're not going to get value out of that at all. You got to do them with me and stop it and go through the step I did, logic it out to yourself. Essentially, these, and I've said it many times, these are very intense sessions, okay? We're going at a bit of a pace because obviously we're going to pack as much as we can in the info that we can download. But by going through it with me and doing it at the same time in the method, you should become au fait with it. Thanks for watching. Cheers, and I'll see you in the next session where we're going to do question. We'll think about it. Cheers. Bye.